So we were looking at reference angles, and we were talking about how we always want to get a reference angle that refers back to quadrant 1. So we want to be able to look at an angle and decide whether it, refers back to one of those primary angles that we know, either the 30, 45, 60 degree angle or some other angle in quadrant 1. So 120 degrees. 120 degrees would be in quadrant 2, so if I think of this as 120 degrees, here's my 120. So it is 60 degrees from the x-axis, so 180 minus 120 comes up with my reference angle of 60. 7 pi over 4, if we look at our unit circle, 7 pi over 4 is over here. So 7 pi over 4 is pi over 4 degrees from the x-axis. So we're not subtracting 180, or we're not subtracting pi from this, we're subtracting 2 pi from this to figure out where it refers back to. So it refers back to pi over 4. So our reference angle is pi over 4. The original angle is in quadrant 4. So that tells us that our signs are going to be positive and then negative. So that tells us what degree measure we need to have. 13 pi over 6. Okay, so I gave you all a hint that anything that has a denominator 6 probably refers back to pi over 6, which this does. So completely around one time would be 12 pi over 6, and then we're going one more apart, so our reference angle is pi over 6. So how do we use that? So if I have a sine of 210 degrees, so think about this for a second. 210 is over here in quadrant 3. So 210 is how many degrees from 180? So 180, 210 minus 180 gives us 30 degrees. So 210 is 30 degrees from 180. Therefore, it references back to pi over 6, or 30 degrees. So then they're asking you, what is the sine at 30 degrees? So sine at 30 degrees is 1/2. We can look back at the unit circle we did, or we can look back at our chart, or just knowing their numbers. So in quadrant 3, both of my values are negative. So therefore, my answer has to be negative pi over 2, so negative 1/2. Okay, 405. 405, all the way around one time is 360, so 405 has to be over here somewhere. So 405 minus 360 gives me 45. So this is 405 degrees, but it is also 45 degrees. So it is in quadrant 1. All the signs in quadrant 1 are positive. Cosine at 45 degrees is square root of 2 over 2, so my answer is positive square root of 2 over 2. Okay, tangent 5 pi over 3. So 5 pi over 3, so we have pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So 5 pi over 3 is over here in quadrant 4. 5 pi over 3 is 1 pi over 3 from the x-axis, so it references to pi over 3. So signs here are positive, negative. Signs here, so we're looking at the tangent of pi over 3. So tangent is sine over cosine. Sine at pi over 3 is square root of 2 over 2. Square root of 3 over 2, excuse me. Cosine is 1/2. Multiply the outsides. I get 2 square roots of 3. Multiply the insides, I get 2. So my answer is square root of 3. Now in quadrant 4, my signs are different, so therefore tangent is going to be negative. So I come up with a negative square root of 3. Okay, so it takes a little bit of thinking. You've got to decide what's the reference angle, what are the signs in that quadrant that we're dealing with, and then you have to know your unit circle and your values of your ordered pair. Okay, so we're going to go back and do a couple more examples like the problems that we did a minute ago. So what if I tell you that the cosecant of theta is square root of 2, and I tell you that theta is some value between pi and pi over 2, and I want you to find cotangent. Well, pi and pi over 2 is over here in quadrant 2, so I know I'm dealing with an angle in quadrant 2. Cosecant is 1 over sine, so in this particular case, sine has to be 1 over square root of 2. So this is my picture. Opposite over hypotenuse, 1 over square root of 2. So then I can do Pythagorean theorem and figure out the missing side, or know what it is. But that value is going to be negative because we're in quadrant 2. So now, here's my triangle, so I can figure out the cotangent. Cotangent is adjacent over opposite, because it's the reciprocal of tangent. So I get negative 1 over 1, which is negative 1. So the cotangent of theta would be negative 1. Here I have tangent of theta is 1, and sine has to be negative. Well, tangent is positive. If we go back to this chart, tangent is going to be positive here, and tangent is going to be positive here. So tangent is positive in quadrant 3 and quadrant 1. Sine is negative in quadrant 3 and quadrant 4. So that means that my angle has to be in quadrant 3 because that's what they have in common. So I draw my right triangle in quadrant 3. Tangent is 1. 1 over 1 is tangent, opposite over adjacent. But because I'm in quadrant 3, they both have to be negative. So then I do Pythagorean theorem and get the third side as square root of 2. And so now I can find the cosine. Cosine is negative 1 over square root of 2. And then I rationalize and I get square root of 2 over 2. Okay, here's another example. So tangent, this time, looks very similar. Tangent of theta is 1, but the sine is square root of 2 over 2. So that means tangent's positive, so we're talking about quadrant 3 and quadrant 1. And we're talking about sine is positive, which is going to be quadrant 1 and quadrant 2. So they have quadrant 1 in common, so this has to be in quadrant 1. Tangent is 1, that's 1 over 1. Sine is, square root of 2 over 2, so that's my hypotenuse. So find the secant. Secant is 1 over cosine, so secant would be, cosine would be square root of 2 over 2. So secant would just be square root of 2. Sorry about that. Okay. Alright, the last one. We have secant of theta is 2 square roots of 3 over 3, and sine of theta is negative 1/2. Well, sine is negative in quadrant 4 and quadrant 3. So secant is 1 over cosine, which means cosine has to be the reciprocal of this. And then if I rationalize that, I get cosine is square root of 3 over 2. So cosine is positive in quadrant 1 and quadrant 4, so they have quadrant 4 in common. So I draw my right triangle in quadrant 4. Sine is a negative 1/2, so negative 1 over 2. Cosine is square root of 3 over 2, so there's my square root of 3. And the question is asking for the cotangent. So cotangent is cosine over sine. So I could do it this way, square root of 3 over 2 over negative 1/2. Multiply the outsides, multiply the insides. And then the 2's cancel out and I get negative square root of 3. So I hope this helps.